Hi guys, you welcome back to my channel. In today's class, we'll be analyzing two compounds. And in my previous video, which I've dropped earlier on how to prepare a standard solution of D and E. And D is oxalic dihydrate. How do we know if D is actually dihydrate? So the things we are going to take a look at now is, the first thing is, let's read the question together. They said D is a solution of 1.6 gram of 250 cm cube of this, which is your oxalic acid. E is a solution of 0.196 mol per dm cube of KMNO4. Now, let's take a look at how we can easily go about the titration. One thing you need to know is that the KMNO4 which is a strong reducing agent, will be in the what? The burette. And here we have the oxalic acid, while here we have sulfuric acid. So we are going to pipette this oxalic acid into this particular conical flask, and we are going to measure either 15 or 10 cm cube of sulfuric acid. If you are a tutor out there, please be careful. So the first we are going to pipette this into this, which is the oxalic acid. So you need to be very, very careful when you are trying to what? Pipette. And as well, you measure the sulfuric acid. This sulfuric acid labeled in. You measure either 10 cm cube or 15 cm cube of this, which we have on the whiteboard. And we are going to heat it to the point at which it's going to what? Show you that it is what? Boiling already. So let's have this in either 10 to what? 15. So I'm going to measure 10 cm cube. And please be careful. So you place it here. So I have 10. So you pour your 10 cm cube here. So the moment you pour your 10 cm cube here, then you can then titrate the potassium permanganate against the oxalic acid, and going to 3 to 5 minutes. Are you seeing it? So let's continue. If you observe vividly, we have measured, we have set the time for both the oxalic acid and the sulfuric acid to boil at 5 minutes. So now, be careful with it because it's the conical flask is very, very hot. Now, you see, so you have to be careful with it. So you need to be very, very careful with it because it's very, very hot. So we have, so when you see the first coloration, are you seeing it now? It's a change color. Are you seeing it? So we continue. Our main objective is we are to attain at pink coloration. So you can see, not there yet. So when you are doing it, you need to be very, very careful. So be careful. So our coloration must be pink. We are not having it yet. So I think we are getting there a little. So we're having a what? A slight pink here. So that is the main thing. Please, can you bring the camera closer. So let's see what we have here. Let's bring closer so you can just show the many scores here. Bring it closer, please. So I think we are having we're having 25.60. So we can place this back, please. So we have 25.60. So this we have this. So this will be 25.50, 25.40, 25.50, and here we have 25.50. So now the next thing we are going to do now is we have the volume of KMNO4 used. They give us the first titer plus the second titer plus the third titer divided by 3. So based on what we have here, the first thing here is what? 25.50 plus 25.40 plus 25.50. Please, your value must be consistent. So in that case, we can easily say we have 25.50, 25.40 divided by 3. So here we have 76.40 divided by 3. So we have 25.46 cm cube. Now, the first we are going to calculate, I said, calculate concentration of E in gram per dm cube, which is the first one. So the concentration of E in gram per dm cube, E is what? E is a solution of 0.0196 mole per dm cube of KMNO4. Now, the formula for that is mass concentration of E in gram per dm cube equal molarity times molar mass of E. Molarity of E. Mind you, molarity is the same thing as molar concentration. Are you with me now? So the first thing you need to do is that since we are talking about E is a solution of 0.0196, so this serves as the molarity of E. Now, let's calculate the molar mass of E. What is our E? Our E is KMNO4. Are you with me now? So you can say molar mass of E, which is KMNO4. Our potassium as given on the whiteboard is 39 plus 55 plus 16 times 4. That will give us 39 plus 55 plus 64. So in that case, we can easily say we have 39 plus 55 plus 64. So I have 158 gram per mole. So now, to have this now, can easily say molar concrete is 0.0196 times this 158. So what will be our value? 39 plus 55 plus 64. So in that case, we can easily say we have 39 plus 55 plus 64. So I have 158 gram per mole. So now, to have this now, can easily say molar concrete is 0.0196 times this 158. So what will be our value? Times 0.0196. So we have 3.09. So, and this will give us also. So this is our gram per dm cube. That is the mass concentration in gram per dm cube, or we take it as mass conc. So this is our final answer. Now the next thing states that So we are done with this. So the next one is we have to take a look at, let's say, calculate amounts in moles of E in the average titer value. So if you have to calculate this now, it is very, very simple. Please, if you don't understand it before, I would advise you to take note of the question. So now, let's say we have high, so the formula is, or let's make use of it here, please. Let's solve it here. So we have N is equal to CV over 1000. N is equal to, what is our C? The C is 0.0196 times the volume of the KMNO4 is 25.46 divided by 1000. So N is equal to, so let's see, 0.0196 times 25.46. So we have 0.049916 divided by, so our value is, N is equal to 0.0050. So now that we have our N, which is the number of mole, and the next thing is calculate concentration of D in mole per dm³. Now, for us to calculate the concentration of D in mole, so to calculate for this, you can say we have, so concentration of reducing agents, volume of reducing agents, the number of mole of reducing agents, concentration of oxidizing agents, volume of oxidizing agents over the number of mole of oxidizing agents. Now, what is the concentration of reducing agent? It is what we are asked to calculate for. So, in that case, if you are to make this the subject of formula, and the volume of the reducing agents, it is what we pipette into the conical flask when we titrate, which is what, 25. Now, the concentration of the oxidizing agent is 0.0019, which is what, this. And the volume of this given is 25.46. So now, let's make this Cr the subject of what formula. And the number of mole of reducing agent is 5. Are you with me? And the number of mole of the oxidizing agents is what? 2. So when you cross multiply, so we said C reducing agents, volume of reducing agents, number of mole of oxidizing agents. Mind you, this one is 5 and what? 2. So equal COA, VOA, and NRA. So VRA, NRA, VRA, NOA. So we have this CRA. That needs to be what? The value for this is 0.0196 times the volume of OA is what? 25.46 times 5 over 25 times 2. So the concentration of RA, so we have 0.0196 times 25.46 times 5. We have 2.49500 divided by what? 50 divided by 50. So we have our CRA equal 0.049, and this is approximately to be C Ra equal 0.050 mole per dm cube. Now that we have this, so the next thing to do is we have to calculate for the next one, which is what? Value of x in the oxalic. We don't know the value of x, so we said, initially when we started the question, I said, so this is a solution of 1.6 gram in 250 oxalic acid. So if you are just coming across the video, I would advise you to kindly rewatch the video. And when we try to measure the oxalic acid, not in 250, we are not to dissolve in 250, rather we have to dissolve in 1000 cm cube. So we have 1000 cm cube, and here we have x. So when you cross multiply, you said you have 250 cm cube of x is equal 1.6 times 1000. So when we divide both sides by 250, this will cancel this. X is equal to, so when we check, we said 1.6 times 1000, we have 16 divided by 250, we have 64.6.4. Now, the next thing now is to calculate for molar mass. And to calculate for molar mass, I will have to clean this. To calculate for molar mass, so he said molar mass, this will be in gram, molar mass equal mass over mole. And the mass is what? 6.4. And the mole is, the value you have here is what? 0.050. So let's see what we are going to have. So we have 6.4 divided by 0.050. So we have 28 gram per mole. So this shows that the value for oxalic acid without adding this is what? For this is 128 gram per mole. Now, let's calculate the value of x. To calculate the value of x, so we said you have H2C2O4 XH2O 128. So this will give us 1 times 2 plus 12 times 2 plus 16 times 4. So x 1 times 2, and this will have what? 16 is equal to what? 128. So for us to have this value now, we can easily say, okay, so the next one will be percentage composition of water of crystallization. So that will give us 2 plus 24 plus 64 plus 1 times 2 plus, that will give us 18x is equal to what? 128. So let's add up everything together. 26, that's 90 plus 18x is equal to 128. Now, to help ourselves, I will advise you. So that will give us, and the next one is volume of CO2 liberated at STP. Please take note of that. So we have 18x is equal to 128 minus 90. 18x is equal to 128 minus 90. We have 38. Divide both sides by 18. This cancels. So we have our x is equal to, we have 2.1. So when we approximate, we have what? 2. Now, the number of mole we have to calculate for, please take note. The number of mole we have to calculate for initially was, that's on our left side we have H2C2O4. So the x here is what, guys? 2. So meaning this will give us H2C2O4.2H2O. Now, the next one we have to calculate for is what? They said percentage composition by mass of crystallization. So we said percentage composition. That will give us this. over this times 100 over 1. So to have that percentage, please, composition. So this one will give us, since our x is 2, are you with me now? So say 2, open H2O is what? 18 initially. So that will give us 16 plus 18 over, this one is what? 128 times what? 100. So we said 18 times 2 times 100 divided by 128. Okay? So I'm coming, since this is this, x is 2. I'm coming 18 times 100 divided by 128. So you can say we have, this will give us 18 times 2, that's 36, 128 times 100. So the final answer is, so 36 divided by 128 times 100. So percentage composition is given to be 28.12%. Please always stress you, no have any arm to your hand. Just hit the subscribe button. Follow us on our TikTok page and do well to drop anything in the comment box. Thank you and God bless.